Can startups truly commercialize recycled or bio-based plastics for regulated industries? To answer this question, I brought in Alex Braun. Alex is the chairman of Pillar, a Israeli industrial R&D and technology development company focused on smart polymers, sustainable materials, and applied chemical processes. Over more than 2.5 decades, he has led development and commercialization projects across different industries and has co-founded ventures including PlasticBack, Snow Polymers, and Inteligels that we're going to talk about today in this episode. In this episode, you're going to learn how advanced material research can get commercialized through an industrial R&D and venture building model, what PlasticBack and Snow Polymers do differently in terms of recycled and bio-based materials, and what it takes to get the material commercialized and how your company can get involved. My name is Lucas Pianigonda, and I've helped over 40 medtech companies to be more sustainable with plastics. And here's our conversation. Hi, Alex, and welcome to the podcast.
Hi, hello, Lucas. Good day. It's a pleasure to be here. Thank you.
Yes. Thank you very much for coming on. So you have a company that is a R&D and industrial research organization, so to say. It's called Pillar. Tell us a bit about what Pillar does and how the model works.
Okay, so Pillar is a company that we founded 26 years ago. It's I always say it's the opposite of startups. In a startup, you start with this idea and try to find different ways to commercialize it. So what we do in Pillar, we work directly with large-scale manufacturers, mostly international companies, and we create materials and solutions, technologies for them by demand. And we also give them the intellectual property to own from day one. That way, we differ from maybe academies and universities that maybe do the same. We are a private company, fully industrial. All of the team is industrial. About 72 developers. Most of them are chemists, biochemists, biologists, physicists, engineers, and of course, a coordination team. And when I say the opposite of startups, imagine that our clients are not VCs, they are industries. They require very, very narrow and specific solutions. So every challenge is very narrow. It comes with a very clear specification document. And they say that's exactly what we need. And we need that change and we need it to work on these machines. We're not going to change machines now. It has to be on this specification, on this regulation, and this price range. And with all of these narrow demands, I always say it's like playing golf. You can hit the ball from anywhere, but the hole is very small and you don't get no points near the hole. So it must be on the spot exactly. And then we start with several directions. We usually offer more than one solution. We offer 3, 4, 5. The client get to meet the team. They get to see the solution. Some of them really look like the starting parts of a patent. And only then they commit whether to go with us or not. So it's a very industrial in nature solution for industries to have the ability to develop something which is out of their scale, maybe not in their specific focus, but in a great need, always a great need. So that is what we do.
And you focus on polymer, chemistry, chemical processes, and sustainable materials. Is that right?
Yes. So we call it departments of knowledge. So our first department of knowledge was actually polymers. So in polymers, that was started already 26 years ago. We started and we had quite a bit of work in all regarding recyclables and biodegradables, but then also in reinforced, in encapsulation formulations, in reactive polymers, the polymers that change shape and are trigger released or trigger based to do things. So from packaging, we went to adhesives, to cosmetics with polymers, to medical device, to pharma. And these departments also followed. And each time what we have in the company is we never know what is the challenge. Sometimes we try to guess on the way to a meeting, but we never guess. It's always different. We can never expect it. Industries ask for changes because of regulation, because of competition, because of innovation necessities. And imagine that the industries are the top and mostly they're the top and the best in the world of what they do. We cannot compete with that. We don't try to. Imagine being very good at what you do is like having a telescope and you are looking at something very far away, very, very clearly. But what you don't see is all the sides. okay, because you have this machine and you're so expert at it. So what we do, we try to bring this challenge, the solutions from the places where they are not looking, or they do not expect, and they count on us on doing so. Sometimes the people that solve the solutions are not expert at this field at all, and usually it's a team of people solving the solution. And on all of this development work, we have the CEO, Asher Razlan, who is also a chemist. He manages the teams, he manages the technological aspects of all the work. He manages me, of course, and everyone else. He's like the head of our small family, and he takes care of getting things right and on time, on demand, as the clients like it.
Yeah, that is what I see a lot with very big companies and established companies. Is like they say they have an R&D, but they actually only have a D. The R part is very much missing, and I think this is what is very interesting to complement that from an outside perspective. Is what sometimes they do, big companies, is they just look for startups that have a solution that is in their space that complements their technology well, and they just buy that startup, and or they partner with an external research organization such as yours. But with the model, so you do research for big organizations and develop technology for them, but sometimes, as you told me, they're like stuff comes up that wasn't like really in the plan and that would be of commercial value, and then you start to spin out a company. So tell us a little bit more about how that works, and then we're going to dive into the 3 startups that you're currently involved in.
Thank you. So, okay, just before we do what you mentioned before about just the D, it's very clear, and that is correct. You have to take risks if you want to develop something, and exactly that model allows it, because what we do, because the intellectual property belongs to the clients, to the industries, they can ask for grants, and most of the topics have high importance for government. So governmental grants and local grants and international grants create actually most of our work. So the industries request them, it's their knowledge, they're totally allowed to do this. And we are just acting as their outsourced R&D department. And they have also the option to stop the work at any time. And that allows a very low risk model. And yes, with this model, we create technologies. And what you just said about spin-offs is that sometimes what happens is that we create more than what they ask for. The solution that we provide can service many other needs. And in this sense, we have a permission, we ask for their permission to do something with this knowledge that have been investigated deeply and to turn it to more users so it can supply more needs that either governments or communities or industries have. And this is what we call a spin-off. So the solution was already created for something very specific, but we already understand and we see it can serve more needs. Then we ask and we create a spin-off. A spin-off can be turning the knowledge to another party and then offering them to use it for the benefit of everyone. But also it can be creating a new startup, an independent startup. This is an independent company. We don't get to have shares. Our development company never has a property, not intellectual property, not shares of any company. We're strictly clean just for R&D and just for service. But when we promote and we suggest to create a startup, we also support it. So we support the startup until it's created, until it's independent and can go on its own. Of course, together with all the ecosystem that we find with our partners and investors, if needed. So that is a startup. Yes, we did create several startups during the years. We had the one that was very famous many years ago that created a whole industry and had a very nice run. And we had a small exit from it. But now we have 3 other startups, and they're all in the material space, and a lot of them has to do with either benefiting the environment or benefiting people. So I'll be very happy to talk about them if you wish.
Cool. Good. So first of all, would you tell us what the maybe famous startup from a few years ago was? And then let's dive into PlasticBack.
Okay, so that startup was actually creating a biodegradable polymer from agricultural waste. So it was 24 years ago. At that time, biodegradable polymers were considered something which was really extraordinary. People didn't really focus on that at that time. And we did this together with the Hebrew University of Jerusalem. And it was a great adventure, but it was in the past. It was so long ago we learned a lot from this experience. It was one of the big projects of our company. And I think today's startups that we have are actually benefiting from the experience we had from that startup that was already sold many years ago. And today we have startups like PlasticBack, like Snow Polymers, like Inteligels, which are also in the fields of materials, different. So not only polymers, they are so all of them are polymer related, but they also come from organic chemistry and from other knowledge based that supports these startups as well.
Okay, well then let's talk about PlasticBack. This is the one that I'm most excited for because you can dive into what the technology does. Like in a nutshell, it is a low temperature, low environmental footprint, chemical recycling of PVC. And PVC is like it is a problem medical waste since PVC burning causes a lot of, let's say, nasty chemicals, and it's also quite flame retardant, and therefore the chemical recycling of PVC to a feedstock that is usable for the chemical industry, again, is extremely interesting for someone who's interested in recycling of medical waste. So please go on and explain how the tech works and where the company stands.
So PlasticBack is a low temperature chemical solution for recycling plastic waste. There's a lot of technologies that can recycle plastic waste chemically, but they all work in 500 degrees Celsius and up, sometimes even more than 1,000. And that limits what they can do. It limits their LCAs, it limits their capacity of working with diverse polymers, like, for example, PVC. Okay, PVC is a great example, which is rarely being actually recycled. And it's one of the most common materials. So it's the fourth largest material being produced, but only like the last one that is being recycled. And that because it contains not only polymers, but also chlorine. And that actually destroys machines of pyrolysis and of incineration. So they don't touch it. What low temperature does, we work under 100 degrees. So what we don't burn anything. It's a chemical recycling solution that works under kettle temperatures. And what we do with this, we are agnostic to contaminations. We can do 100% PVC. We're one of the only companies in the world that can recycle 100% of PVC, and we're on stage a lot about it, discussing it and presenting the technology. So PlasticBack was created in 2020, and it was a collaboration between the Hebrew University of Jerusalem and our development company and the client that we worked for before on creating something totally different. But we saw the potential of it. It was marvelous. It's a marvelous invention. Professor Yoel Sasson and Dr. Uri Stein are the inventors of this technology, and it's a present to the world. It can create recycling solutions for many plastics that are not being touched at all. It has won many competitions around the world, in Europe, in Israel. It worked with diverse clients from around the world, and it's scaling up. This is still just a startup, but it's scaling up pretty fast. It has very nice investors from Europe, from the United States. We have an industrial investor called 3Point, and we're building now our first device, a pilot demonstration unit of 30 tons to be attached to the 90,000 ton facility in Ohio, US, of 3Point, and that will allow them to intake 100% PVC, up to 100% PVC waste streams, and maybe create also a small kind of history here and create it back to chemicals, back to oils and chemicals. This solution is not only converting plastics to oils, we retrieve all of the additives, all of the chlorine is turned into NaCls, to brine that can be again used to create new PVC. So it allows many options that were not even in the focus of any recycling unit, whether it's, of course, mechanical, but also chemical. That is the gift it brings to the world. And it's an honor to be in your podcast and also to share this invention and to call out for collaborations of industry, of investment options. We are a small company. I think if we want to change such a big market, we would be very happy to get any partners that are wish to do the same. And we're here for it.
I mean, that sounds a little bit like, to me, it sounds too good to be true. You know, it's like I'm getting skeptical right away, since like low temperature recycling of PVC sounds really cool. Did you do a life cycle assessment? And the second question would be, when you scaled up, what's gonna be the price point of your chemicals versus, let's say, fossil chemicals? Currently, it's a little bit like distorted since situations around the world. But have you done that analysis?
Of course. So what is nice about working with our spin-offs is, please remember, they didn't start from day one as startups. They did start in an industry focus that was very, very limiting. So actually, the first materials that we recycled with this system were high density polyethylene, which is very, very hard to recycle. I actually remember when we started, it was like 8 years before we started the company, where this professor told us only God can recycle high density polyethylene in room temperature. And we said, yes, we believe God can do it, but also we can try. And when we saw that it's possible, okay, that was a sensation. It was something we never saw before. And it was created on a very tight spec. So we do not see ourselves as a green company. Of course, we are a green company, but we see ourselves as dealing with a lot of wasted material that is lying on the ground and being landfilled or incinerated. There is a total no need for this. So we are on the oil spec price. This is not a company that needs to be on a premium. There is a premium on synthetic oil. So refineries, oil companies around the world need to intake more and more synthetic oil, and there is not enough of it being created. That's what drives the pyrolysis industry. So there is a premium on synthetic oil, but we don't need it. Of course, we will enjoy it, but we can create chemicals and oils that are competing in the oil range price, and of course, competing in the oil range spec. But again, it's not perfect. We're still developing, we're still scaling up. There is a lot of challenges. You said too good to be true. We have a long way ahead of us. It's fast to say, it's much harder to do. You will see it in almost every other startup that we do. The invention is it's very deep, but it needs to be worked, and that is what we do. I think the team works hard. In PlasticBack, we have Tal Cohen, one of the best CEOs I've ever worked with in my life. So leads a very talented team of people, of engineers, of chemists that are working day and night, and investors that work day and night just to tackle all of these challenges. We still have a way to go, but slowly, day by day, we're getting there, and I hope we will continue.
And you did also do an LCA on the PVC recycling?
Yeah, this is actually, we have a negative LCA. So for every liter that we create of oils, we actually have a 0.3 carbon reduction. So that is something that has never happened. And we have been offered to participate in creating fuels in tenders by municipalities and large-scale companies. And we're looking forward to that day, because we can actually show fuels that are green in a very completely different way. So we'll be very happy to reach that point and use this aspect of it. And not only that, we have already pre-signed 30% of our plastic credits that we create to a trading company in the Netherlands, the FS company, in an LOI. So that is also being created because plastic credits from PVC recycling are supposed to be very, very high. So that is another contribution that we can say, again, with the premium prices that they are for syntheticals, with the plastic credit, it just gets more interesting for investors. But again, we don't need all of them. We can compete just on the basic price. It's a hard competition, but we can do it.
I think this is like what's stopping the adoption of sustainable plastics right now is scale and price currently. I think like if I work with a medtech company who wants to incorporate more sustainable plastics, is the two questions that come up the most. It's like, is it going to cost? Okay, we might be able to invest in future-proofness of our materials. However, it's like if it's not available, that's going to be a showstopper. So availability is going to be very key. And it's also the price that is going to be key. But the more that you build it, the more capacity you build, the more you prove that this is viable, the more we will also see adoption.
Oh, if you want to see, just I brought for the ending of this part, a small sample of our oil. This is how it looks like. Okay.
Cool.
So this is created. I wanted to impress you with our 30-ton facility, but the airport security was saying you have to be convincing enough with this amount. So that is a bit of our oil that is created. It looks actually more like Saudi Arabian oil. So there are different oil types and they are in different viscosity. So this looks like and feels like Saudi Arabian oil. Oh, I don't know if it was created from polymers from there, but that's how it looks like. to the specialist.
That's really nice. I think, 30 tons would have been difficult to fit on screen, but it's really nice that you brought a sample. And you see that the chemicals that get out of this process are not dissimilar, or very, very similar to what we dig out and drill out of the ground. And this is a question I get so much. It's like, oh, is it going to be the same? Yeah, sure. Of course it's going to be the same. It's like, as you told us, and this is like a very interesting insight. It's like oil all over the world is not the same. It's like there's different qualities of oil coming from different places, and the refineries have to deal with these different qualities. So they're very used to producing polymers from different qualities of oil. And that also proves that you can take a variable output and then generate a variable input and generate a stable output. And this is what the chemical industry is very, very good at. And therefore, I have no doubt about that we can do the chemical recycling and this exact same quality as we do with conventional fossil resources.
And not only the oil, please remember the NaCls are a very costly part of PVC manufacturing. We can, of course, handle not only PVC, but PVC is a very good, clear example. Because it contains so much chlorine, okay, turning back the chlorine to NaCls is a valuable commodity for the same factories that produce PVC, because they invest so much in producing these clean, pure NaCls from their sources. We just give them back the NaCls that they themselves produced, just like the oil. You just, as you said, you were right. We just attack the carbon-to-carbon bonds, we separate the materials, and we just give them back to the industry. Here, there's your material back to you. Continue with your process. Okay, no, do not need to feed from external sources. Just take yours back. That's why we're called PlasticBack.
That's very, very inspiring. Yeah, let's move on. You have also two other companies. I'll let you choose which one you want to talk about first, Snow Polymers or Inteligels.
I think Snow Polymers is a very good company. It's much younger than PlasticBack, but it's scaling up really fast, and it creates something which is I think it's sort of a business and personal level altogether, because this is the second biodegradable polymer company that we create, and this time we're going for a much harder target. So Snow Polymers, I can explain it very fast, but it's much harder and longer to do. It takes upon itself the glass ceiling of biodegradable polymers altogether, and that is the price. Eventually, there are so many solutions. Everyone understands the importance, the communities, the industries. We all understand the importance of biodegradable polymers, but there are limits, and price is the biggest one. Okay, there are so many solutions right now outside, but very rarely they touch upon the price issue. And still, biodegradable polymers that are sold commercially are 2 times, 4 times, 6 times more expensive than oil-based plastics, and that's why we don't see them so much in the world, in the commercial world, in the market. So what we do, and of course there are other limitations, like that you need to adapt new machinery. So industries don't like to change capex; they would like to stay with their own machinery. Plastic producers don't want to close down their factories and open up new ones. And we saw that in the first company that we built, that it was hard. There we needed to change the machinery. The price was higher. Here, it's not the same. Snow Polymers creates biodegradable polymers in the oil price, plastic prices. And it does so by actually eliminating other industrial waste and without the need to change the machinery of any plastic producer. So it creates a grade, okay, that can be also added to stand on the regulation of 2030 that requires packaging companies and also others to embed more and more either bio-based or recycled content. But there's a lack of it. There's not enough, and there's always mechanical instabilities. So we try, we produce here, I can show you, this is a grade that we produce. Okay, we produce many grades. We can produce many grades. This is an example of a grade of mulch film. And this grade can be added to any film that is created. So 30% stand on the regulation of 2030. Okay, it can be added. What it can also be done is to create its own 100% biodegradable polymer. So what I'm holding now is a mulch film. Okay, this is a mulch film that is created for one of our collaboration industrial factories of Snow. And it's creating it on the same machinery. This is blown film, one of the toughest processes in the plastic world. And we demonstrate that even today, when just the company has started, we're already going for blown film. But of course, it can be cast, it can be molding, it can be melt spinning. So these materials are on the target to replace polypropylene, polyethylene, and to be combined with these products without changing the machinery and without changing the prices. And this is even before what is happening with the prices now in the Middle East of oil and polymers. So that is the target of Snow Polymers, and it's a much younger company, but it's very close to the heart of everyone who is involved in it. And one of these people is, of course, Dr. Shai Garti, the inventor and CTO of Snow Polymers. He's also a very good friend. He was doing a wonderful job in this technological marvel and of advancement.
So what I found with biodegradable polymers is that they're very good at certain applications. Like mulch film is one of the key target applications because it's getting on the ground in agricultural applications, and then you don't have to get rid of it, and it will degrade over time. So you don't have to basically dig up your foil again, and that is a very cool application. It's like in medtech we have certain applications that are bioresorbable, so like implants, polymers that will resorb over time, or sutures that you don't have to pull, and that is very interesting. However, it's like if you don't need that biodegradable property and you want it to be durable, it's like the biodegradability is going to be a drawback because the chemical resistance and the processing and the shelf life of the polymers, it is different from I say, the non-biodegradable, non-compostable plastics. So like for what kind of applications would you say is like Snow Polymers is the right choice? Or where would you say, oh yeah, you probably are better with something that is bio-based but not biodegradable?
Thank you. It's a very good question and a very good point. I agree. So we also went to mulch film, not because this is the best product to do with it. It's just a very good entry point to the market. So creators of mulch film want biodegradable polymers anyway, and they create films that are biodegradable, and they talk the same language that we talk. But what we can show to anyone, and we can also send samples to any plastic manufacturer, even today, if you look at a technical data sheet, you see the density ratios, the MFIs, the TMs, the tensile modulus, the elongation, the yield force, the compatibility with standards. You will see that we are just a polymer of any other polymer. So like any other polymer, it can be biodegradable, but we don't have to be. When you combine us as an additive, it doesn't create with other plastics, it doesn't create a biodegradable polymer. It just creates a bio-based intake for a plastic manufactured product. So that is the idea of Snow. It doesn't need to create biodegradables. It's just a very nice bio-based solution. And please remember, we use our source materials from industrial waste altogether. So there are industries like food processing, like paper, cardboard, that actually pay to get rid of or sell it just take it away from us prices. We can actually create a solution for them as well. I had a very good friend who used to say, instead of killing two birds with one stone, to release two birds from the same cage. So we take industrial waste from one company and we do a back-to-back deal with the plastic manufacturer, and we do it in very small circles. So that allows us to work locally, create deals that are either based on licensing or joint venture models, and also we would like to be creators of materials ourselves. So this is a deep tech that allows many applications, from casting to molding to blown film to melt spinning. So many applications are possible. And of course, as a startup company, we have to focus, we have to start somewhere. But in the end, and as we grow and continue, we see ourselves creating at least 4 grades during the next 2 years and going to the market with other partners, again, either by licensing or by joint ventures or by creating our own circles of production, which we would be happy to do. Why not? Why not make and create materials if we just can? But as a company, we cannot create all the materials in the world. We just need to start at a point. That's why mulch film is a good start.
I mean, that is always how you have to look at it. It's like you need to understand the technical, and you obviously do. And then the second thing is you need to understand the economical, and that you obviously also do. And the third question that would be, okay, in terms of life cycle assessment, did you also perform an LCA on this polymer?
So this polymer is built to be on the regulation of biodegradable polymers. So it is compatible with US standards, and it is compatible with European standards, either compost or industrial compost. So all the ASTM or the EN standards this is what it is designed to do. And we're talking at a cost. Currently, the cost is still much lower than the price of oil-based. We see it in our partners and factories that are some of our investors were invested by an incubator that is owned by 4 factories. So this is a great opportunity for us and for the industry. I hope we manage to take it forward.
Mm-hmm. Yeah, and the polymer is 100% bio-based or from biocircular feedstock, you said.
We work on molecules that are either cellulose or starch. We build on their backbone. Okay, we build the connections. We call it brush molecular architecture. So it looks like a little bit of a brush. Imagine a molecule of a bio-based material with this hair that creates a connection to the polymer world. And these are novel 2 molecules, and it's a deep tech of creating new materials altogether. And that allows us to fit. So most of the material is actually organic. Most of the product, our grade is either cellulose or starch. All of the rest are a combination of a batch of other biopolymers that are created, and we're growing all the time with these ratios. So we're trying to get as high as possible to just our polymer in the batch itself.
Okay, that sounds very interesting. It sounds also very promising because I think, as I mentioned it before, price is going to be your biggest issue in getting your sustainable plastics to market, because this is like the thing that everybody is complaining about in the plastics industry is like, oh yeah, we made it more sustainable, but now it's costing more and nobody is going to pay for it. So like, for oil is not going to go away because it's just the cheapest. And as soon as this is no longer the case, you have no argument to not take the more sustainable option. Because, there's usually a trade-off. And if you don't have a trade-off, then you actually have a breakthrough technology. And as it seems, if you can do biocircular feedstock that is price competitive with oil-based plastics, it's going to be very, very interesting. And a lot of the companies are going to be very interested in using that plastic since, the motivation is there to make it more sustainable. But it's just like, sustainable does not only mean more ecological, it also means profitable. It also means good for the patient. And meaning technical performance needs to be the same, economical performance needs to be the same, and then better for the environment is what they're looking for. It's difficult to do, and you need deep research to make that happen. And seems like you have achieved that. So congrats.
Oh, it's
still a long way.
Maybe too soon, but yes, thank you very much for your kind words. We are again here. We have a lot to do. Not perfect at all. There's a lot to go. And again, we see ourselves as tackling an issue at a time. We cannot change, and we do not want to change the whole of the industry. We want to create, first of all, great additives, great initial biodegradable products. I think collaborating with industries is a pleasure. It's also our passion. But I agree with you. The price, that's the reason we created this company after 26 years in the polymer field, creating knowledge. And even another startup that was the beginning of it, we didn't need to start another biodegradable company. We started because of the price, because I believe there are other companies around the world that this should be their target. Okay, if we all manage to have this target together, polymers are such a huge field. There are so many things to be done. So we just see ourselves as one of the companies that raising the flag to tackle this, to make it the main target. Price, adaptability to the same machinery that is currently available, and standing already and working in the production assemblies. We should be there. We should do the effort. I think that's our calling. This is what we're here for. And we're honored to have this option in life to at least try it. I think the relationships that we build allow it to be possible. And industries are coming there, and they're here. They're talking to us. We are so proud. Again, such a young company. We did not expect so many industries to relate, and we see them there. And it's interesting for them. And it's a totally different experience than what we had 24 years ago. And this time it looks like people are needing this and waiting for this and looking for this. And we're very proud of the connections that we have made. I hope we get to continue with this as much time as we can.
Yeah. The typical 30-year overnight success.
Yeah, a lot. Yeah.
As like many plants grow through roots in the dark and then shoot up in a few days, and you have to build the roots first. You have to build the foundation first before you can basically shoot up and be an overnight success. Because there is where everybody starts to see you, but you started building a lot earlier. Anyways, let's go to the third one, Inteligels. I'm also very, very excited for that one, since that is in the wound care sector. Is that correct?
Yes, it is. So totally different altogether. So Inteligels started as the sense of pain relief. The most painful procedures statistically in hospitals are the replacement of bandages. And when you need to replace a bandage over a burn, it sticks to the bandage. And then you have to peel the bandage out of the patient with the skin that is attached to it or the wound that is attached to it. You can imagine just the screaming that happens right now in the hospitals just outside our windows. Okay, this is happening every day, children, grown-ups. That is the situation, and also very painful for the staff because it takes a lot of time. Okay, it's very unpleasant. It wastes a lot of money for the hospital. So what we created, so this is actually a creation of the Hebrew University of Jerusalem, Professor Daniel Cohen, a great inventor, many medical applications, even much more so complicated than Inteligels. Okay, including implantable polymers, so reacting polymers. This is a polymer that comes as a liquid. When it touches the skin, it turns into a solid, flexible, breathable. Okay, you can see through it. You can see the wound. Of course, we can color it, but you can actually see through it. And it becomes a bandage of any bandage. There are no adhesives. It just copies the skin and attaches to the bandage itself. The secretion that comes from the body are absorbed in it. But then when you need to change it, you just cool it down with some cold air or cold water. So the temperature creates a trigger that makes it go back to liquid. So opposite to nature, okay, it becomes liquidated by cooling it down. And we can actually design. So just imagine that like this was what we always say about our development company, and it's true also in this case, as other people design software and AI, so we design materials. So we can design the temperature window, we can design the activation phase, we can move the window up and down and narrow it and enlarge it. We can create other triggers like pH or magnetic fields. So there are many things that we can do with these polymers. This one is when you cool it down, it just becomes liquid. And then you can just wash it in the sink since it's also biodegradable polymer. Okay, but of course, this is not in the price range of packaging. Okay, it's a total different price range. But for bandages, it's actually less expensive than any other advanced material. It can actually compete with regular bandages. Bandages themselves have their own price. And we are in this price range of regular bandages while we are doing a very, very sophisticated bandage altogether. I have also samples here if you want to see how it looks. So this is a syringe. Okay, you can see it's totally clear. Okay, when you put it in the fridge for a few minutes, it just becomes liquid. Then when you want to take it, it's already ready for use. And this can go and happen between liquid to solid as many times as possible. We tried it 700 times, never saw any difference. So it reacts always to the temperature. And we have also different grades. So there are grades for fast use that solidify very fast. We have materials that create a very thin layer and take more time, and then it's very hard to detach them. You just need to cool them down. You can't just take them out. And of course, if you are not burned, if you don't have a wound, it will not stay on your body. Okay, it's like the polymer saying, "Why did you put me here? There's nothing here." Okay, it takes the shape of the wound. So if you put it around the wound, it will become the shape of the wound. It will fill the wound with material, create a second skin, and that is what it can do. But because it's a smart polymer, it's a very good base for any active materials. So pharmaceuticals, okay, pain relief, any active materials that you want to take out of the system and spread on the skin, okay, for pharmaceutical use, for cosmetic use, it's like a Lego. Okay, we can actually put different particles inside, and we can also make special encapsulations to release these materials on either a time release or a trigger release phase. Like we have more blood, the pH of the skin is different, and other triggers that we want to design. So this This is a company that was also created. It is already on Material 8. Okay, so we have already achieved an ISO certificate for production. We have achieved already an FDA clearance. So that is for the basic products. For more advanced designed active material types, we would need to go for deeper regulation. As you're a regulation expert and dealing with the medical device, so these medical devices are in the long run. So these advanced applications, we have now Tatiana Braun, who is leading initiatives in Europe in all regarding these advanced applications of the smart gels. And I believe we will see them coming up during the next year with very nice collaborations that she's already heading. That is the company, and yes, this is I think the starting point of eliminating pain and suffering. That is the idea of this company, and that is what it's doing, and it's using smart materials to do it.
Yeah, I think this is a beautiful solution, since wound care, especially for burn victims, and as a Swiss person, it's like this year started pretty bad. because
yes.
There was like a huge fire in a disco and very, very near where I live, and there were like several people. I haven't the exact number now in mind, but it was like dozens and dozens of people who were died and got severe burn wounds, and it's one of the most excruciating experiences that you can have. And the standard procedure of treating such a wound is that you will have to get rid of the wound care, in that case is bandages, and then you have to get rid of all the necrotic tissue, which is like all the dead tissue you have to get rid of. And this is either done by two methods. Number one is you scrape it off with a scalpel, or you have a high pressure water washer, basically, so you power wash the wound until all the necrotic material is done. You can imagine how painful this is. So if you can like do better on the patient outcome and patient, let's say, pain and suffering side, that's also something. The patient outcome is going to be a lot better. The patient experience is going to be a lot better when you have something that helps prevent necrotic material even forming. And on top of that is going to be sprayable. You can wash it off with cold water. So it's a beautiful show of material science. And it's one of the reasons why I fell in love with material science and originally decided to study material science, because it's just so beautiful that you can have this phase shift with temperature and build something that is so beautiful and helps people have less suffering in their lives. So it's a very, very cool and beautiful application that you have there. So you said you have FDA clearance. How does it look on the MDR side?
So not yet. So FDA actually for the basic material is an exempt. We don't need an FDA, but we registered it anyway. But MDR will be, of course, depending if we go for the basic material or we go for upgraded active materials. But before we continue, I think what you said about the terrible event that happened with the fire. Imagine we are working with a German company to design. It's like there is a fire distinguisher for fires, but also we can design with them a burn distinguisher. So this gel can be inside a container that is always being cooled, always ready for use. Okay, just like a small fridge. Okay, the minute you have a complete, like a hard burn, like in this event, you could take it out and just spray it on the person. And it's not only painful to afterwards to take regular bandages off, it actually retracts, okay, the wound itself, because you're tearing it up. So, and also makes the person stay in the hospital much longer. So in this case, you just cool it gently with cold air or cold water. It doesn't need water. It can be also air. Okay, just cool it and just remove it. Okay, it becomes watery. Okay, so it's been removed anyway. Or just leave it if you want to leave the bandage on the skin. But it allows a different kind of operation. The minute when we saw that terrible accident, okay, we immediately said we are not fast enough. We should have been there. We should have been available there with these kind of materials, and we were not fast enough to get there. But I hope we will be in the future more available as we go forward.
Yeah, I think that Gran Montana event also, like, that taught more than one lesson in material science. It's like one of it would be that if you build something, you take flame inhibited plastic and don't use any old plastic. So yeah, requirements are important, and don't skip them. Yeah. So Alex, let's come a little bit to a more personal part. What did motivate you to get involved with Pillar, and how is that experience in founding so many different startups? Aren't you a little bit overwhelmed over all the things that you're involved in?
So I'll try to answer the two questions in the same answer. I think my parents brought me I was actually born in Latvia, and they brought me to Israel when I was a baby. And they came from ideological reasons, so they lost everything to come. We started with nothing. I remember a very happy childhood, but there were no things like chocolates or toys in the house. Books, we had books, but not chocolates and toys. But the father's laboratory, he was a professor in the Hebrew University. I had all the toys in the world. It was it's an amazing world of materials that were disappearing out of thin air, and magnets that are flying in midair, and watches and assemblies. And I was like fascinated by all of this. I think when I grown up, I understood how much good you can bring from these kind of devices and these kinds of laboratories. I always feel very comfortable in laboratories. I am a master's of business and not a scientist, but since most of my professional life I was managing R&D projects, it somehow stuck. And I think doing better, doing good in the world while providing technologies is the main reason that I have it. And also maybe some childhood, missing the toys that were not there. But I think what I managed to with my business skills that I was privileged to acquire during and also practice is to know how to build systems. And I do not have full participation in all of these companies. Okay, I assign teams, and if I'm able, I'm always happy to participate and lead projects from time to time, or to lead necessities of these companies from time to time. But all of these companies are fully staffed. Okay, they do not need me. Okay, I'm always invited, and I'm more than happy to join. But it's building systems, and I try to practice to be better at it. First of all, they have to succeed. Success is something. I heard that success is for a person doing what he loves and is passionate about. That's already success. But they should be in the market, okay, before I consider them a success. So it is a push, and we are pushing it. I wish I could found more companies. I'm trying. I'm on the way, but these companies need to succeed as well.
Very good, very good. So Alex, what advice would you like to give to our listeners in general about startups, about commercialization of material science? What advice would you like to give?
If I ever succeeded in something in life, it's because, in my opinion, I've surrounded myself with people that are much better than me in anything that they did. And as a startup, I would say it's just the same. I would suggest myself, and I'll practice this myself with the companies that I'm part of, and I've been pleasure of co-founding, to be surrounded by industries, to be talking and working and collaborating, and be together with companies that are much better, that are much stronger, that know what they need, that know what they want, and listen well. Because as a startup, I see, and sometimes we ourselves were falling for it. Yeah, the idea is so great, we think we know, but rarely it happens. If we listen to the market, if we listen to the current players, to the people who should buy it, or to the companies that should combine with it, then we get the ideas much, much better. And this is also what I think what investors are looking for. Traction, okay, that's what they call it. And I think it's a necessity. It's not only a recommendation. Working with large-scale manufacturers has taught me that is the best way possible to understand the real need of the market. And I am passionate about industries. I love industries. I'm trying to be an industrialist myself with these startups. So after 26 years of serving industries and creating materials for them, maybe I've grown envious of them. And I think having the ability to produce real life materials in the real world, it's a great benefit, it's a great present. And I would recommend it to any startup. Work closely with the industry. Yeah, they're better than us, and they should be. And we can support. They can allow us to grow, and we can allow them to have things that they don't have yet. And maybe a little bit less ego. In Pillar, all the scientists, all of our team, and that is the best present that we have, the best asset. is the team. It's some of the best scientists I've ever met in my life, but all of them are willing to put on the side their ego and work for an industrial cause without having, their IP belong to them ever. And working with them has taught us, or taught me, to put my ego aside also in the startups, which is like startups are really full of ego. And I think startups should be a little, our startups should be a little bit more humble, more listening, more learning. And that is what we try to be. And hopefully we have a better chance to grow, maybe because of it.
Yeah, I don't know if that only applies to startups. I think that is a general good advice for life. Be more humble and listen more. Okay, Alex. So, do you have any last words?
Just to thank you very much for this interview, which has been wonderful, and the ability of this to be shared. I really appreciate it. We're all on the names of our startups and on the name of Pillar. On behalf of the name of Pillar, we wish to thank you very much for having us and for allowing us to talk and answer these very interesting and wonderful questions.
Yes, it was a pleasure as well. So this was Alex Braun from Pillar. And until the next time.